Hornets, and thank you for joining me today. Today we're going to be taking a look at analyzing rational functions using our curve sketching procedure from AP Calculus AB. This means that we're going to be finding various aspects of things. We'll be finding our x-intercepts, y-intercepts, vertical asymptotes, horizontal or slant asymptotes. We'll then be finding our intervals of increase, intervals of decrease, relative maximums, relative minimums, interval of concavity down, interval of concavity up, as well as any points of inflection. All right, so let's go ahead and take a look at the first problem that I'm going to do from the material that we've been working. We're looking at x over x plus 3. Now the first piece is to find our x-intercept. The x-intercept is what's going to make the numerator equal to 0. And it's pretty clear that that will be a 0. So we can now say that f of x has an x-intercept of 0. Then we go to the y-intercept. The y-intercept is when x equals 0, we get 0 over 3, and so f of x has a y-intercept that's 0. We then go to our vertical asymptote. Our vertical asymptote is what makes the denominator equal to 0. F of x therefore has a vertical asymptote at negative 3. Please make sure you write it as x equals, as it is a vertical line. We then have a horizontal slant limit or horizontal limit. And this is because they have the same power of x in both the numerator and the denominator as our highest power. When this happens, it is the ratio of leading coefficients, and therefore 1 divided by 1. If you wish to use calculus to do this, you're going to multiply by 1 over x, and you will end up with trying to find the limit as x approaches infinity for 1 over 1 plus x3 over x. This ends up giving you 1 over 1 plus 0, and that horizontal limit is 1. You would then try at negative infinity, and you will see that it's the same thing. So we do have a horizontal limit, or asymptote, and this is at y equals 1. Now for us to do the next 3 parts, or 4 parts, the intervals of increase, decrease, relative extrema, interval of concavity, and points of inflection, we now have to take the first and second derivatives. So we're going to start with our first derivative, and I'm going to do it down at the bottom. That means that I have to take the derivative of x, which is 1, and multiply by x plus 3. Then I subtract x times the derivative of x plus 3, which is 1. It is all over the denominator squared, and that's x plus 3 squared. I'm now going to simplify this so that I have an x minus x gives me 3 divided by x plus 3, the quantity squared. So this right here is my second derivative. I have only one critical value, and that is the asymptote sitting at x equals negative 3. To make my sign chart, I put in negative 3, but when I put my factors, I do not include the x plus 3 because it has a power of 2. We always leave out even powers. So when I plug in a value greater, 3 stays positive. Less, 3 stays positive. So no matter what happens, I'm looking at increasing intervals on either side of my asymptote. Finding my second derivative. I now have, and I'm going to change this so that it's a little bit easier to work with, and I'm going to call it 3x plus 3, the quantity to the negative second power. This will then give me, when I take my derivative, negative 6 x plus 3 to the negative third power times the derivative of x plus 3 is 1. This simplifies into negative 6 over x plus 3 to the third power. Doing my sign chart, I have negative 3. Once again, that's my asymptote. It is always in our sign charts. We never lose a derivative or a asymptote when we take a derivative. That's important to remember. We have negative 6, and then we take away 2 of the powers, and it leaves us with only 1 of the 1 over x plus 3. Negative 6 is just always negative, and when I plug in a value greater than 3, I get a positive, less is a minus. This will provide a double negative, which gives me a plus, and a negative and a positive is a negative. I now can see concave up and concave down. We're now ready to write our information. So, f of x, and let's see, has no relative extrema. F of x is increasing on, and you'll notice I'm going from negative infinity to negative 3. I cannot write, I have to use parenthesis at negative infinity, and I have to use a parenthesis at negative 3 because it's an asymptote. F of x is decreasing on, and I'm now doing negative 3 to infinity. There is no point of inflection because this is an asymptote. And by this, I mean the x equals negative 3. Notice we might actively think that that's a point of inflection, but it is not because of it's an asymptote. So there is no point of inflection. Then we're going to go to our last bit, and this is now concavity. F of x is concave up on negative infinity to negative 3. F of x is concave down on negative 3 to positive infinity. So this is what we want to graph. Finding the horizontal limit, finding my vertical asymptote, locating my x and y intercepts, concave down on the positive side, and increasing on both sides. Concave up. Now we label things. And there we go. We now have our graph. And this now fits the information given. Let's take a look at another one. This time, let's look at one that is not a fraction, but is instead a quadratic. This time we're going to take a look at f of x equals x squared plus 2x minus 3. Now, as we find our x-intercepts, we use the quadratic formula. Now, I'm going to use the b squared minus 4ac. That's called the discriminant. And if I get a negative number, I know that I have no x-intercepts. So let's find out. 4 minus 4 times negative 3 times 1. And I'm looking at getting a value of 12 plus 4 is 16. Alrighty, so this does have x-intercepts. Let's go ahead and see if it factors. It looks like it's going to factor with a positive 3 and a negative 1. I now have my f of x, and I can say f of x has 2 x-intercepts, and they are 1 and negative 3. F of x has a y-intercept of negative 3. This is because I let x equal 0. F of x has no vertical asymptotes. F of x has no slant or horizontal asymptotes. All right, now we're going to have to go to our first derivative test. Taking my first derivative, f of x has to equal 2x plus 2, and I can therefore factor out the 2 to give me x plus 1. The critical value is negative 1, so here's the work. I'm going to set up my sign chart, putting negative 1 in the middle, and I have 2, and I have the x plus 1. 2 is always positive. X plus 1 is positive greater than negative 1, less than negative 1. We get a negative and a positive. We're now going to go to our second derivative. F double prime of x is going to have to be 2. And we can clearly see that f of x is always positive. So I can now start to answer questions. F of x has a relative minimum at negative 1. Once again, notice the pattern, positive to negative. F of x is decreasing on negative infinity to negative 1 with a bracket. F of x is increasing on bracket negative 1 to positive infinity. F of x has no points of inflection. And then f of x is concave up on negative infinity to positive infinity, because it's always positive. Once again, always positive. Sign chart is just positive. Now we put in our graph. We have a negative 3 as an x-intercept, positive 1 as an x-intercept, y-intercept is at negative 3, relative minimum is at negative 1. So if this is 0, negative 3, we know opposite side over here at negative 2, negative 3. It's negative 3, 0. Positive 1, 0. Let me change that, please. Positive 1, 0. And we need to find that location. So I'm now going to plug in negative 1 into the original, and I'm going to find what I get. I get negative 5 plus 1 makes negative 4. So this is negative 1, negative 4. And I'm now just going to draw my curve, making sure that it's got that curved base. And here is my graph. Notice I've labeled my points. Granted, I might as well just show that axis of symmetry, not that I asked for it. X equals negative 1. And there's our graph and our analysis. That is analyzing functions. I hope this has helped. And if you find that you liked this video, please remember to click like. Thank you very much, Hornets. Please be safe, take care, and have a fantastic weekend. Bye-bye now. Cheers.